Thanks everyone for being here, for having this paper in the program. This is joint work with Philippe, obviously, and Richard Blundell and Rachel Griffiths. And this paper actually results from a surprising fact we found in the data. So first we wanted so we had work on the subject of whether income inequality, top income inequality could be explained by innovation, and with Philippe, and our finding was that in the US, part of the increase of income inequality could be explained by innovation. And so we wanted to look at whether this finding could be consistent with what a lot of papers showed, and especially the recent paper by Song et al., which is that wage inequality is mostly, increase in wage inequality is mostly driven by the between firms variance in wage. And so we wanted to look at whether innovative firms did pay high wage, which is finding that is quite clear from theoretical model of endogenous growth. And it has also been shown previously using a similar kind of data, but mostly in the 80s, especially by John van Reenen. And this subject matter because rising inequalities have been shown that in many countries to be driven by difference in wage, which could be explained by between firm differences. And
can I make one comment? I mean, I think the right way to read Song et al. Is that just like previous people and also the other countries, it's not mostly driven by between. Still, the within is very large.
The increase is driven by
increase. No, it's only at the very top. If you look at the top percentiles, then the between becomes very important. But for the mean inequality, within is as important. So.
Yeah. I'm not sure, is it true also for Germany because you can measure exactly the top because of the top coding? And most of the action in Germany is at the bottom of the wage distribution.
Yes.
So I would guess that for the US it's true for Germany.
But that's not the paper about Song et al.
You started.
Okay. So let me explain what we are doing in this paper. So in this paper, we document first that innovation is one important driver of between firm difference in wages, but that's not exactly what it's exactly what we're going to be mostly focusing on. So to be more clear, what we are doing is that we are showing in the data that indeed innovative firms do pay higher wage. And we do that using match employer-employee data for the UK. And this is quite clear, as you will see in a minute. And then that comes, what surprised us is that when we did the same analysis by skill level, what we found is that actually this increase is particularly true for workers in low-skilled occupations. And actually the effect for workers in high-skilled occupation is not very clear. It's not significant from the regression we will show. And so we thought about it for quite a long time. And we came up with an explanation, which is one explanation, but maybe other explanation could also be told. And our explanation is that what matters is complementarity between high-skilled workers and low-skilled workers. And we built a model that captured the idea that low-skilled workers can have a potentially more damaging effect on the productivity of the firm, on the production of the firm, all the more than the firm is more frontier or more innovative. And so I'm going to first show that some empirical result, and then we'll show additional support for the model. There is a long literature which we are at the crosswalk of many, but since most of the authors of this literature are in the room, I don't think I need to emphasize that. So let me start with innovation and wage. So let me drive you quickly through the data. We have, so the main data set we are using is the annual survey of hours and earning, ASHI, which is match employer-employee data, a bit like the DADS, except that it's only a 1% sample of the UK population. It's a panel, and we have many detailed information about all labor income, and including bonuses. The second data set we are using is the firm-level data set, the Business Enterprise Research and Development, BERD, which is a census of firms of more than 400 employees, given very detailed information about their innovation strategy and R&D expenditure. So because of this 400 threshold, we will restrict our sample to firm over 400 employees and to the private sector. And at the end of the day, our sample includes 150,000 employees and about 6,300 firms, which is, of course, a huge restriction, but we still have 70% of all the R&D conducted in the UK. And we can show some robustness to larger sample, but with, of course, different measure of innovation. Just like other...
There's a very strange fact.
Yeah.
If you multiply 6300 by 4, that gives you 24. Then by 10, that gives you more than the number of employees. So there must be some sort of time issue here.
Yeah, no, yeah.
If there are more than 400 employees,
you
should have many more employees, right?
Yeah, but we have only 1% of the UK population, so that's what we have in the data. So you should multiply this by 100 to have. Okay. So that's why. But I agree. It's so a larger share of the UK workers are in large firms actually. So I told you that in Aghion we have many information about the wage, composition of the wage, but what we don't have, which is a common drawback of those data, is any information on education or a direct measure of the skill of the workers. So what we do instead to measure the skill is that we're going to use the skill level of the occupation. So the Aghion data report very detailed occupation level of the workers, and what we did is that we use the rules that the UK set for people who want to immigrate to the country, and to set the when you apply for a job in the UK and you're from abroad, you are ranked in one of the six skill categories, which have been defined looking at the average level of education of British workers in those occupations. And so we have gathered them into 3 categories: low skill worker, which are basically process operative clerical jobs and cleaning occupations; intermediate skill; and high skill, which are mostly manager and engineers; and a very small category, which are PhD-related, PhD occupations, so scientists and those kind of occupations, which is a very small part of the data. So to show you that this categorization makes sense, this is the average wage, hourly wage by skill category. So that's given in pounds per hour. And what you see is that obviously it increased with the skill level, except for the very end. And the annual earning at the end of the year is also increasing with the skill level. Okay, so that's our data for labor income. Our data for R&D intensity, so it's taken from BERD, and it's simply the logarithm of 1 plus R&D expenditure divided by employee. So R&D expenditure is defined at the firm level, so regardless of whether it's done in the establishment where the worker is, we take all the R&D, and we also take R&D that is outsourced by the firm, which is purchased for the extramural R&D, which is a small share of total R&D, but increase with the total amount of R&D.
But this is rather away from the innovation process, right? And this is R&D expenditure. It's an input.
Yeah, it's input. Exactly.
And the second thing is, well, this is from the analysis. So you've got R&D process, and since you add the 1, this means actually in your data you've got a lumpy investment. Right? So in your data, basically, if you add 1, this is because you've got a lot of zeros. Yeah. The normal transformation of this R&D intensity.
Yeah. So actually, when R&D is not 0, it's it's not continuous from 0 to epsilon. So there is a huge gap between 0 and the smallest R&D intensive firm. And so this doesn't really matter actually. We could have replaced it by the logarithm of R&D and employee and replaced by 0 for other firms. We can show also robustness to very different measure of R&D, different functional form. And really this functional form doesn't really matter. Doesn't drive any of our results. And for, I also use extensive margin of R&D. So I set a variable equal to 1 if the firm ever reports any R&D since 2000. That's mostly for graphical analysis. So let's start with the first result we have. So this is the first way to show that indeed, so the R&D intensive firm pay higher wage, or R&D firm pay higher wage. So the y-axis is the share of workers in R&D firm at each level of the wage distribution, okay? So what you see is it increase up to the 80th percentile, and then it plateau and decrease for the very top paid employee, which is mostly because in the UK they are all working in the financial sector, which is doing no R&D, and this explains the decrease you see at the end of the distribution. So actually what R&D can explain is mostly up to the 80 percentile. So we're not going to work more on to tell a lot about very top income and how it's related to R&D. It's mostly differences between anywhere in the distribution, but not at the top of it. Another graph which is more related to the kind of regression analysis we're doing is looking at the elasticity of wage with respect to R&D. So x-axis is logarithm of R&D intensity, which is 1 plus R&D divided by employee in the firm. And this is the wage relative to hourly wage relative to labor market average. Okay, and then it's been scaled to by adding the wage. And what you see is that, so 0 here is a huge mass of firms that report 0 R&D. And then as you move up the distribution of R&D, you see that you have, on average, larger wage for all the workers in those firms. Another way to say that, to see that, is to take the extensive margin of R&D. So the green line is the average wage for worker at each age when they work in R&D firms, so firms that ever report any R&D expenditure. And the red line is the other, so the wage for the other workers. And you see that at each age, there is a premium for working in an R&D firm. And this premium increase mostly after around 40-year-old. Okay, so now you can say that this doesn't say more because R&D firm can be very different they are very different from other firms. And actually, they are different in a way that could also explain why people are more paid. So they are a bit larger. They have more men, more full-time workers, older workers, and more experienced workers. At least workers that spend more time in the firm. And so we want to control for all of that. And for this, we ran the following regression. So this is the logarithm of the wage per hours for worker I in firm F. This is R&D intensity of firm F at T. And then we control for all those guys. And this is the results we have. So first column is using labor markets time years fixed effect. And what we see is that there is indeed a positive coefficient linking R&D to the wage. And then we use more restricting set of fixed effects. So this is labor market area, time occupation, time year fixed effect. You see that the coefficient decreases a lot. And it continues to decrease when you use individual plus year fixed effect and when we use firm plus year fixed effect. Okay, so this is a confirmation of results that were already known. And now we are moving to what happened by skill groups.
But is it concerning that? Is it not a little concerning that as you add more fixed effects, the effect is moving down?
I think the identification are a bit different, especially between column 2 and column 3. So column 3, you follow an individual in time, and so it could be driven by either within a firm increase in R&D intensity, or it could also be driven, and actually it's mostly the case, it could be driven by workers that switch from non-R&D to R&D firm. And yeah.
I think that if you wanted to fully solve or tell us a story, you should really start from the full sample, the 1% sample, estimate, if you believe in those, you're not forced to do that, but Pascal and others have been doing, first and firm effects. And then restrict attention to those firms for which you have data on the innovation. Because there you'd be able to subtract from wage the person and the firm effect, and then look at this kind of things you're doing.
Okay.
That would be, I think, more suited to your needs. And also there's the issue of the firm effect in that, in the model I'm talking about here too, by the way, where you could regress. There's also a level effect, which is standing variable, which you don't account with still.
Level effects, I mean, comparing different firms?
Yes.
Okay. So the last column is controlling for firm fixed effect. So indeed, you see that the coefficient is... Yeah, the coefficient is...
There's also the non-time varying component that is included in the firm effect. The time invariant component of innovation that could be included in the firm effect.
Yeah, no, but I take your first point. We should, I think, we should try this clearly.
But I mean, I think the concern here is, I mean, we know from other papers that, successful innovation has some wage effect. But, here in your sample, R&D intensity is proxying for lots of things.
Yeah, exactly.
And the fact that, your effect essentially between column 2 and, column 1 and 2, which are sort of similar, in some sense, other than the addition of the firm fixed effects, it sort of goes down by a factor of 28, sort of says that R&D might be proxying for other things than successful innovation.
So in fact, you will see in the model that R&D is not really what, I mean, we use R&D as a proxy for something that we could call frontiersness or something, technological advance of the firms. And actually in the model, it will not be exactly R&D or innovation. It will be complementarity of the firm structure.
If you look at, so Darwin insisted on the difference between column 2 and 3. What decreases the coefficient most and increases the R squared most is the introduction of the person effect.
Yeah.
So then, I'm not sure it's exactly selection, but it means that accounting for persons matters a lot.
Yeah, but I think they told
So
very different.
Selection across firms that have R&D and not.
Yeah, so for sure there is selection. So this old within R&D firms and this old, and I think the column 2 and 3 really tells different story, and there is no reason for which the coefficient should be even close. Column 2 is within occupation. So for people in the same occupation, working in more R&D firm gives you a premium in your wage. Column 3 says that in your life cycle, when the firm you're working in increase its R&D intensity, you will have a positive effect on your wage. But also if you change your firm.
When you have two effects.
Exactly.
Between firms and within firms.
Yeah, exactly. And it actually mostly driven by firm switcher from non-R&D firm to R&D firms. So those are very different. And they will help us to understand, I think, what happened when we will move to low-skilled workers, just now. So first of all, and this is important to keep in mind, so as we move through the right of the R&D intensity distribution, you see less and less low-skilled workers. And you see more and more high-skilled workers. And there is no much size effect, so it's really that you see, it's not just a share, you see less low-skilled workers, which could suggest that R&D firms, highly R&D intensive firm or highly technology advanced firm, outsource or get rid of some occupation. And our conjecture is that, a conjecture that we can show in the data, but unfortunately we don't have disclosure yet. But this decrease is mostly driven by cleaners and security and those kind of occupations that are very likely to be outsourced. And why does that matter? Because when we show the same graph as the one we showed previously, but differencing by skill level, you see that most of the increase of wage with respect to R&D is larger for low-skilled workers. So this could suggest that R&D benefit mostly low-skilled workers, but because there is less and less low-skilled worker, on aggregate, R&D intensity or technology advance benefit mostly high-skilled workers. They have a higher share in the total income as technology advance. Okay, and this is consistent with the same kind of regression using individual fixed effect. When we separate by skill level, you see that the increase is significant and stronger for low-skilled workers, and not very significant for high-skilled workers, although when we use all the data at the same time and interact a dummy for a skill level, you see that there is an aggregate significant effect. But still the effect is stronger for low skill workers.
So I guess here it would be interesting to see your equivalent of column 2 before, which is
exactly.
Detailed occupation time times controls, because the composition of who is low skill and what they're doing is changing quite a bit.
Yeah, so fortunately we don't have disclosure, but it's coming very soon, so I can send you the result. But what we see
is that really we were expecting that the premium will be bigger for high occupation, and the big surprise that the premium is higher for low occupation, and that's what we try to. That's what.
But there is a selection effect. That's what.
So we think that what happens, that is that in fact the more innovative, more frontier firm, the more innovative firm, they keep the very high. The reliable low occupation, and they outsource the rest. And those guys, they develop.
I think there are two stories consistent.
Yeah.
In fact, one is that they keep some occupations, the more important occupations.
Exactly.
The other one, they keep workers. So among the low skills, they keep particularly those who are very high skill on unobserved dimension.
Exactly.
And so
that's what
how do you distinguish between those two, and what's the
So
perhaps disclosure will help.
Yeah, so but I can tell you qualitatively what it gives, and
I think that there's a third, not totally incompatible explanation, because you don't know whether this is happening at the margin when workers are staying in the firm, or are they moving from a non-innovative firm to a more innovative firm. So what would be interesting is to interact this coefficient with tenure, for instance.
Yeah,
to see what happens at year 0 versus more year.
Yeah.
so that's So obviously there will be some selection effect, but when you restrict to workers that never change firms, so this is on a 11-year period, so they stay in the same firm for 11 years, we still have the same effect, but with much smaller coefficients.
And it's very compatible with the idea that happens at a longer.
I agree. And the issue is that, so this is a 1% sample, and it's not like the DADS. People can disappear because they do not respond. So we are trying to, I think it would be nice to replicate this with French data where we can see everyone, and we can really focus on firm switcher, because here we see very few, we see switch, but you don't see them the year when they switch. Sometimes they forget to report the, so just to answer the previous question, when we do that by occupation, what you clearly see is that this effect is driven by selection into the more complementary, what we expect to be the more complementary occupation. So if you do this regression for cleaners with individual fixed effects, the coefficient won't be significant, or it will be very, very small and almost not significant. So let me move to the model. Maybe it will help to understand better what happened. So as I explained in the introduction, we had to think of a model that could explain why increase in innovation intensity or increase in functionalness could have an effect mostly to low skill occupations. And so the key idea is complementarity. So we need, what we will assume in the model is that there are some skilled workers and non-skilled workers. And so let's say there are two workers in the firm, one high-skilled worker with quality capital Q and one low-skilled worker with quality lower Q. And in the production function, there will be a part of the production that comes from complementarity between those two workers, which is the product of the two skills, and a part of it which comes from substitutability between those two workers. And this relates to the O-ring production function that's been developed by Michael Kremer. And what we did simply is to add this variable lambda, which captures the extent to which the structure of the firm shows complementarity between high-skill and low-skill workers. So for example, if lambda equal 1, we are exactly in the case of the O-ring production function, where there is perfect complementarity between the two workers. And so I guess you can, if we can show that lambda is indeed correlated with innovation, but it doesn't have to be innovation, it just has to be the fact that frontier firms have a lambda that is closer to 1, then you can understand why you will see an increase in the wage of the low-skilled workers, which is because otherwise it could have a very damaging effect on the production function. And the fact that lambda is correlated with innovation or with functionalness is consistent with finding of previous paper, namely by Luis Garicano and also Van Rieden and Caroli. And we'll show evidence that, that this is indeed the case in our data. So what happened next? The firm engaged in separate wage negotiation between the two workers, the low skill and the high skill workers. If negotiation failed, this is the key assumption on the model. What happened is that the firm have to rely on a substitute, which could be either an outsourcing workers, or it could be someone you have to hire just to replace at the last minute. And what we will assume is that, so the skill of this guy is QL, and we assume that the difference between the skill of the high skill worker if you have to replace him and the skill of the low skill worker if you have to replace him is larger for low skill workers, which means that if negotiation failed for the high skill workers, it's very easy to find someone to have the full information to hire someone. You cannot be surprised and by mistake hire someone which is very bad. But for low-skill occupation, it's more complicated because you don't observe a lot of things in the resume that could tell you whether the substitute you will take is a good substitute. And this is why we assume that the differences is larger for low-skill workers. And then what happened is simply Nash bargaining in the negotiation, which sets the wage just with respect to outside option of the workers. So the firm surplus is simply the difference of the wage. And the worker surplus, difference of the profit function. And the worker surplus is the difference of the wage between the equilibrium wage and its outside option. And then we can derive this expression for the equilibrium wage of the low-skill workers, with beta being the bargaining power of the low-skill workers, and lambda, so the proxy for innovation and functionaries of the firm. We can do the same for high-skill workers, the high-skill wage. And in fact, so first of all, with reasonable assumption on the different bargaining power between the high skill and the low skill workers, you see that the wage in level is indeed larger for high skill workers, which makes sense. But if you derive this wage with respect to lambda, what you see is that whenever this assumption holds, the first derivative of wage with respect to lambda is larger for the low skill workers.
So there is sort of an alternative interpretation of the results, which may not account for everything, but is consistent with Karp, Klein, and Henning, and Schmeidler, and Goldschmidt and Schmeidler on Germany, which is that what you're finding as the low-skill innovation premium is driven by workers who are being thrown out of these high earnings firms, losing wages. So in other words, what's going on in many of these firms is that there is rent sharing, and rent sharing from the profits goes to low-skill workers, and many firms don't like that. So they have been increasingly throwing many of these occupations through outsourcing or temporary, and then the wages fall a lot in these occupations. So that's like, it's consistent with Karp, Klein, and Henning in Germany, and then the paper by Goldschmidt and Schmeidler provides direct evidence. So what's going on is that the low-skill workers in IBM and in these high-tech companies, in these innovative companies, are keeping their wages more or less constant. But the low-skill workers that are being thrown into these security services, food services, and all of these, they're having fairly large drops in their wages. And of course, the skill premium increases, but it's not because of this complementarity per se, but it's because firms are finding a way of getting rid of the rent sharing.
So we have an extension of the model where another way to see the QL could be related to outsourcing. So if you,
interesting that those who stay are paid higher. They could say, I pay everybody low. And
so
we try to understand why
those who stay are paid the same in my story. It's just that those who leave are losing wages. So the premium goes up, but it's not because you're sharing more rent with those who stay. It's because those who leave are being screwed.
The question is, what are identifying your effects? Is it the entry or is it the exit of workers? Mm-hmm. That's what I think.
But then the coefficient, the regression, we have for individual fixed effects. So. I mean, that's the reason we focus on individual fixed effect model, because, and this is also why the occupation, the column 2 with occupation says a different story. Because here we see that, so if what you say is true, we will follow an individual that moved from an R&D firm and then he's dropped out of the firm because he's a low-skilled worker. And we see
joining firms, and we know that the low skill who join more innovative get a higher rent upon joining. So we have information on that.
But again, it's always higher rent relative to other low-skilled workers. And during this period, it's the other low-skilled workers who are getting hammered. So it's the premium is correct, but it's whether the premium is being driven by the top or the bottom. It's a decline of the bottom that drives that's one possibility.
Okay, I see. But that's also why we should we should really show the regression where we focus on one firm workers, because they are immune to that. And with the individual fixed effect, I think it can only tell the story that your wage indeed increase. But
No. If you go from a positive innovation to a zero innovation firm.
no, but that's why I said stayer, firm that stay in the firm.
The stayers there is zero. There is nothing you said.
No, there is a small effect, but it's still a positive effect for R&D. Most of the effects comes from switching, but still. But to come back to the question about outsourcing, you can see this model as, actually you can see this as two different tasks in the same firm. And then the QL should be seen as the quality level of the worker you will hire from a service firm. And the prediction that the same kind of wage negotiation tell you is that innovative firm will outsource this guy, the substitutable guy, which is consistent with what we see, that they outsource cleaning occupation or security occupation, but they not outsource. They rarely outsource process operative or production work.
This production function with lambda being higher for innovative firms, isn't that inconsistent with the figure that you showed, which is that innovative firms are actually outsourcing more? The share of low skill is declining even more. So in some sense, what would be interesting is to go back to data where you can observe outsourcing, like the Goldschmidt and Schmeidler, and see whether innovative firms are doing more or less outsourcing. That's a way to distinguish between your story and mine. So in your story, they should be doing less outsourcing because lambda is higher for them. In my story, they should be doing more outsourcing because they're doing outsourcing for rent sharing, rent shifting reasons.
And you could, there's not a way that you could say, you have those who are really, top, there are some type of low occupation for which quality is very important. Right. So these guys I don't outsource. And I outsource all those for whom...
That's totally consistent, but the question is whether lambda is higher or lower. Because once lambda is higher, you don't have that many occupations to outsource.
But because you said lambda should be correlated with the number of workers in each kind of task, right? But if lambda is higher, you expect those two.
Because you're only outsourcing 1 minus lambda. So that's the prediction now.
Yeah, but that's only the model with 2 workers, but if you had more workers...
I think it's the same thing. It's like if you interpret lambda as the share of the occupations in which complementarity is stronger, you should have less outsourcing. Whereas if it's really rent sharing, I have more money, I really don't want to share those with cleaners, I should see more outsourcing.
Okay, so...
It's a very testable prediction.
Yeah, right. Okay, good point. So let me show you more empirical support for the big assumption we make in the model. So what we do is that we use the US data called ONET. So the ONET data, so they are based on US worker, and each worker at each level of occupation are asked a lot of questions to describe their occupation, their tasks. And what we did is that we took those answers in the US and used them as in the same occupation in the UK. And we are mostly interested in the kind of question that can help us to understand whether some occupations are more complementary with high-skill occupation than others. So let me show you a result for the first question. So people are asked, what are the consequences of them making a mistake, an error in the firm? And they rank it to 1 equal no consequences to 5 large consequences. And then we report the average value of the score for non-R&D firm, low R&D firm, so different level of R&D, and for low-skill worker, intermediate, and high-skill workers, right? So all is standardized so that it's equal to 1 for non-R&D firms. And what you see is that the average score increases in high R&D firms for low-skill occupation and doesn't change much for other occupation. which is, again, consistent with the idea that innovative firms focus on occupations that are more complementary. So if you're a cleaner in an R&D intensive firm, you're less likely to benefit from the premium of innovation that...
That's consistent with the fact that it's not just things going down outside, is that those for whom you are more worried that they make an error, there the premium is higher. So that would go in favor of not just being driven by what's going on outside.
Yeah, and another support of our model is that, so if you consider what matters in the model is actually the fact that the firm wants to build firm-specific human capital, which is captured by the Q minus QL in the model. So the more innovative the firm is, the more firm-specific human capital is workers. And so one related fact is that those firms should train their worker more. So we don't have direct information on training, but we see that with the same data, when you ask people how much training did they do when they start working, workers in high R&D firms report more training. So those are only for low-skill occupation. So they report more training than non-R&D firms. And this is especially the big difference is between zero training and some training. And finally, a last empirical fact that we see in the data is that low-skill occupation workers stay more in a R&D intensive firm than in non-R&D intensive firm. And the difference is, it's not that true for high-skill workers. So the blue line is low-skill workers. This is the average number of years the workers spend in the firm. So this is reported by the worker, which is why we can see more than 10 years, obviously. And you see that it clearly increased with R&D, which is consistent with the view that the firm invested a lot to build firm-specific human capital to those workers. And so to wrap up, so what we did is that we used matched employer-employee data in the UK to show that indeed, as it was already shown, R&D firms do pay our wage. And we show that this is especially true for low-skilled workers. And we propose a model that I will show you to consistent with this. And the big assumption we make in the model, I think, are quite consistent with what we see in the data using especially the ONET data. Thank you.